And today we will discuss polynomial. So, what is a polynomial? Polynomial is a algebraic expression. Algebraic expressions consist of a coefficient and variable and perform arithmetic operation. Arithmetic operations like addition and subtraction, etc. And it is a example of a polynomial, and it is the expression of a polynomial 3x cube minus 4x squared plus 7x plus 18. So here is 3x, 4x, and 7 are the coefficient of x cube, x square, x respectively. Plus here is 18. 18 is a constant term. 18 is a constant term. Okay. Now we move to another slide. In this slide, we will discuss degree of the polynomial. Okay. Actually, degree of polynomial is the highest power of a variable. Highest power of variable. And each degree has a special name. Okay. And first we take 9x. 9x is a no variable. Like here's a yeah, it have a no variable like x and y. So that's why it is a constant variable, a constant polynomial. 8x 8x is a linear polynomial, and it have a only one degree. So it have only one degree, and so that's why this is a linear polynomial, and its degree is 1. And now we take another example of a quadratic polynomial. Quadratic polynomial. This is 7x square plus 3x. Okay. So its highest power of this variable is 2. So that's why its degree is okay. There is a cubic polynomial. This is a cubic polynomial, and this is an example of a cubic polynomial. 6x cube minus 2x, and its degree is 3. Okay. And it's a y quadratic polynomial, and its degree is 4 because the highest power of this variable is 4, so that's why its degree is 4. Okay. Now we move to the another slide. In this slide, we have discussed the coefficient, operator, variable, constant, and exponent. It is an example of 5x squared plus 2y minus 7. And the 5, 2, and 5 and 2 is a coefficient of x and y respectively, and x to the power 2 is a exponent. Okay. And here is another expression of polynomial. With the help of this expression, we want to know terms. Okay. And coefficient variables with exponent. So it have a 3 terms. 8x square is a term 1, and 5x is a second term, and 6 is a term 3. The 3 terms is a constant. Yes. Last term is a constant, and 8 and 5. 8 and minus 5 is a coefficient of x square and x respectively. Student, in this slide, we have discussed some standard form of polynomials. So first we take constant polynomials. Its standard form is fx equal to a0. Okay, so it is an example of fx equal to minus 14 because it have a no variable like x and y, so that's why its degree is a 0. Okay, and now we take a linear polynomial, and its standard form is fx equal to a1x plus a0. Here is an example of linear polynomial 5x minus 7, and the highest power of this variable is a 1, so that's why its degree is a 1. Okay, we have already discussed in previous slide. It is a quadratic polynomial, and this is a expression of a quadratic polynomial. Like I mean, it is a standard form of a quadratic polynomial, and it is an expression, and it is a example of a quadratic polynomial 2x square plus x minus 9. Okay, and the highest power of this expression is a 2, so that's why it's a degree of 2. It is a cubic polynomial. Its standard form is a x to the power 3 plus a2 x to the power 2 plus a1 x to the power 1 plus a0. Okay, so it is a example of a example of a cubic polynomial, uh, x cube minus x square plus 3x, and the highest exponent of this variable is a 3, so its degree is 3. Okay, now we move another slide, and we will know the yeah, we will know the terms and the polynomial categorized according their terms. And so polynomials, they have only one terms called the monomials. Okay, one term is called the monomial. The polynomials, only two terms called the binomials, and three terms called the trinomials. Term 1, term 3, term 2, term 3 called trinomial. Polynomials have more than three terms. Expression more than, they have a more than three terms called polynomial. Okay, polynomial. So we take another example of polynomial like 3x cube plus 2x square plus 7x plus 1. It is another example of a polynomial. Okay, because it have a more than three terms: term 1, term 2, and term 3, and term 4. Okay. Student, in this slide we have to uh, find the value of polynomial, and how to find the value of polynomial. We have an expression. This expression is 2y, 3y equal to 2y cube minus 6y square minus 5y plus 7. Okay. When we put the value y equal to 2, and y equal to 2, so we have 2 into 2 to the power 3 minus 6 into 2 to the power 2 minus 5 into 2 plus 7, and we solve it. 2 to the power 3, 8, 8 into 2, 16, minus 2 to the power 2, that is 4, 4 into 6 into 24, 5 into 2, 10 plus 7. Okay, 16 plus 7 is the 23, and minus 24 and minus 10, minus 24 minus 10. So the final answer is a minus 11. Okay, this is the value of polynomial. Student, in this slide, we have to discuss how to show polynomial in the graph. Actually, graph is a collection of points, and these points show in the graph. And first we take linear polynomial. Okay, linear polynomial. Okay, right. This is a linear polynomial, and its expression is ax plus b equal to 0, a not equal to 0. Okay, and actually y equal to, okay, when we put the y equal to 0, and we got a equation 0 equal to ax plus b, and uh, we solve it, and we got the value of x. So x equal to minus v. So, and x equal to minus v by 2. And we got the value of y and x, y equal to 0 and x equal to minus b by a. And these point, so in the graph, minus b by a, and we have a we draw the linear line in the graph, and these are the linear polynomial. The graphic representation of linear polynomial. Okay. Now we move another slide, and in this slide we have discussed the quadratic polynomial, how the graphic representation of a quadratic polynomial, and its standard form is a standard form, or its expression. Is ax square plus bx y plus c. Okay, so a not equal to 0. Okay, and we have already an expressions, and we put the value in this expression, and we got the value of y. So first we put the value of x equal to minus 3, and we got the value of y 7. Okay, so we will solve it when I have an expression y equal to x square minus 2x minus 8, and we put the value of x equal to minus 3. So y equal to minus 3 square, minus 2 minus 3 minus 8, and we solve it. We got the value of y, that is 7. Okay, and further we put the value of x, and we will got the value of y, and we put minus 2, y equal to 0, got the value 0, and we put y equal to 0, and we will got the value of y minus 8. We put y x equal to 2, y equal to minus 8, and x equal to 4. We will solve this expression, and we will got the value of y, that is 0, and x equal to minus 5, x equal to 5, and they solve this expression, and we got the value of y, that is a 7. And these points represent in the graph like minus 3, 7. Okay, and minus 2, x equal to minus 2, y equal to 0. Okay, this point is here. Okay, this, and x equal to 0, y equal to minus 8. Okay, this is x equal to 0, y equal to minus 8. X equal to 2, y equal to minus 8. This is another point. X equal to 4, y equal to 0. X equal to 5, y equal to 7. And connect these point to each other, and we got a figure like a parabola. Okay, so this is a quadratic polynomial, a graphical representation of a quadratic polynomials. And now we move another slides. In this slide, we have to discuss sum of zeros and product of zeros. Okay, when we talk about sum of zeros, that means alpha plus beta equal to minus b by a. Minus b is a coefficient of minus coefficient of x, and is a coefficient of x square. Okay, when we talk about product product of zeros, that means alpha into beta equal to c upon a. C upon a, that means c is a constant terms, and e is a coefficient of x square. Okay. This formula, yeah, using this formula, we will find the zeros of the polynomials. Okay, a relationship between zeros and the coefficient of a quadratic polynomial. Okay. There is a some example of a polynomial and its degree. Following are the form of various polynomials, degree of polynomials, name of the polynomials, form of the polynomials. It is a constant polynomials. It have a 0 degree because it have a no variable. So that's why it is a constant polynomials. Linear polynomials, it is a linear polynomials. Okay, linear polynomials. It have only one variable, and its highest power is a 1. So that's why its degree is a 1. Quadratic polynomial, it is a expression of quadratic polynomial, and its degree is a 1. Well, we have already discussed in previous slides, so, and it is just you know, revise the of this concept. Okay, so now we move the another slide. In this slide, we have to discuss about sum of zeros and product of zeros. Yes, alpha and beta are the zero of the quadratic polynomial. This is a expression of quadratic polynomial. It is a sum of zeros equal to minus b by a. Minus b is a coefficient of x, and divided by coefficient of x square. And alpha into beta is a product of zeros. This is a c by a, that is a constant terms. C is a constant terms, and a is a coefficient of x square. Alpha, beta, gamma are the zeros of a cubic polynomials. Yeah, it is a expression of a cubic polynomial. Alpha, beta, gamma, it is a sum of zeros equal to minus b upon a equal to minus coefficient of x square. Coefficient of x square is b. Okay, and coefficient of x cube is a. Okay, so it is a sum of zeros, and here's a product of zeros. Product of zeros equal to minus d by a. Okay, minus d is a constant terms. This is d. It is a constant terms, and here's a coefficient of x cube, which is x. Okay, and alpha, beta, gamma, delta are the zeros of a biquadratic polynomial. Polynomial, and it is the expression of a biquadratic polynomial, and it's a sum of biquadratic polynomial. Sum is a sum of zeros. Sum of zeros is equal to minus b by a. Minus b is a minus coefficient of x cube. coefficient of x cube and a coefficient of x to the power 4.